Customer analytics, using data to drive decisions. Segment price and predictive, fueling career ambitions. Who buys more and why and when? What brings customers back again? Data or machine learning? Happy customers, jobs worth earning. Customer analytics, using data to drive decisions. Segment price and predictive, fueling career ambitions.
Okay, so today we're going to talk about predictive analytics. We started out with descriptive analytics, looking at unsupervised machine learning frameworks. Then we moved into diagnostic and prescriptive analytics, using demand models to quantify market response to price, optimize price and brand investments. And our final unit today and next week will deal with frameworks that are designed to predict what's going to happen in the near future. We're going to start out with some motivation for why firms focus on customer acquisition to the exclusion of some other metrics they could be focused on instead. Then we're going to talk about how the served available market, that is the number of people who purchase in a category, how that evolves as the category matures. That'll be our VAS model framework, which we will simulate in our script. And we're going to close with customer lifetime value, which is a prediction of the profits that we'll realize from individual customer relationships. And it is a widely used approach to manage customers internally and decide when and how much to invest in acquiring and serving customers. So to explain the importance of customer acquisition, the strongest evidence I've ever seen was produced by some economists at Stanford about 5 years ago. These guys got their hands on the entire US transaction database from the Visa payment card network, including credit and debit card transactions. Enormous data set, 32 billion transactions by about 430 million cards at 1 million stores. These are all retail stores. Over $1 trillion spent over 4 years. Now, we're going to wave our hands a little bit. We're going to make an assumption that we know isn't exactly right, but it's pretty close. We're going to assume that each unique card represents a distinct customer. And of course, we know that the population of the country is about 340 million. So we know we're going to be double counting customers to some degree with this assumption, but it's not going to be wildly off the actual reality and what generated the data. So the research question these guys sought to answer is what customer level factors best predict merchant revenue in the data set? And of course, to get the revenue, the identity, you can add up all of the spending, but we can also expand that out using a series of ratios to be the product of the number of stores that were selling things in the data, times the number of unique cards served per store, times the number of transactions per card served, and then times the spending per transaction. And once you do this expansion, you can take logs on both sides and run a correlational regression to see which of these 4 factors on the right best explains the variation in the brand revenue on the left. And they did this in a few different ways. The one that I personally find most compelling is the second specification, which included merchant and time fixed effects. And in that specification, the number of cards served per store explained about 68% of the variation across brands and how much money the companies made. the number of unique stores in the data was the second best explanatory factor. It was a distant second at only 16% of the variation in merchant revenue. And then the number of transactions per card and spending per transaction collectively added up to about the same proportion of variance explained. So the lesson of this exercise is that the number of unique customers we serve is by far the strongest predictor of how much money we're going to make. And it helps to explain why some of the companies internally justify actions based on customer acquisitions more so than developing existing customers or getting them to come back more often. Of course, we want that as well, but the first order effect is how many different customers are we serving. These economists also ran similar correlational regressions within each of the industries in the data. And it shows the robustness of this effect, where it's around 80% and far higher than any other variable considered in predicting brand revenue. So what we'd like to do is understand how many customers there are going to be, how many we can attract, and how much money we'll make by serving them. Now, predictive analytics in general is something that's extremely helpful, but often misinterpreted and sometimes misused. So to illustrate the utility of predictive analytics frameworks, how many of you guys checked the weather forecast anytime in the past week? Oh, wow. Okay, in San Diego, I actually expect lower proportions of hands. Yeah, we're May gray. Yeah, you don't know if it's going to be chilly in the afternoon or warm. Helps you decide what you should wear that day. Anytime you see a stock price, that's in part a forecast of the stock's future profits and how those profits will be returned to investors, whether it's through buybacks, whether it's supporting the share price, or whether it's through dividends. We opened the quarter looking at an illustration of how we could potentially use crime report data to illustrate how safe different neighborhoods are. One of the decisions that some of you may face in the future is whether to go back to school. And that's a cost-benefit trade-off. How much is that going to potentially increase your salary, your human capital, versus how much is it going to cost you, both in terms of tuition, but also lost wages if you were to go full-time, or not cost you in terms of lost wages if you go part-time, then it's just lost weekends. And another common source of predictive analytics is looking at customer ratings. That's a very loose way to predict the quality of the product that you'll experience after it's delivered, its reliability, how long it'll last you, and how good of a value it is for the money. Now, so we often want predictive analytics to help us make decisions regarding the future, but there are several important aspects of predictive analytics that may limit the understanding and applicability of those frameworks. So I'm going to make 4 comments. The first one is that correlations by themselves can enable great predictions. Correlations are often stable across time periods. We don't necessarily need to know the underlying causal drivers or even observe the causal drivers directly in our data in order to come up with solid predictive analytics. So this is something that's often misunderstood. People think, oh, I have to have data on the causal drivers and enabled in order to predict what will happen. That's generally not true. To illustrate that, let me reintroduce you to my favorite animal, Greymont. Greymont has a very, very powerful predictive analytics engine in between his ears. If I put on my shoes, he can come up with a solid prediction that I'm going to be leaving the house in the near future. If someone picks up a can of treats, he can come up with a solid prediction that he might be a candidate to receive a treat. Now, his diagnostic analytics engine is very questionable. He does not always know why things are happening. He does not always know how to influence the series of events that's going to unfold. But when it comes to predictive analytics, he's phenomenal. So that illustrates the idea that you don't have to know why things are happening in order to predict what's going to happen based on what has happened in the past. The second comment I'm going to make about predictive analytics is that by definition, they are not prescriptive and they are not diagnostic. It's a misuse of predictive analytics if we try to use them to figure out why things are happening or what we should do. They can be an input into those decision processes. But by themselves, they're designed to tell us what is likely to happen next, not why, and not how we should respond. So if you check the weather, you're going to get a number, you're going to get a percentage probability of rain, maybe you're going to look at a wind forecast, but that's not going to tell you what you should wear. That's an input into your decision about what you should wear. The third comment I'm going to make is that predictive analytics are highly uncertain. And in fact, they're often so uncertain that the error bars make them look useless. And so the error bars are typically omitted. When you want to account for the uncertainty in a prediction, there are three sources of uncertainty that should be accounted for. The first one is usually accounted for when precision is calculated, and that's the variability of the error curve in the model. That one's pretty straightforward. The second one is a little less obvious, and it's usually omitted in uncertainty calculations on predictions. And that is the asymptotic variance of the parameter estimates underlying the prediction. So think about the standard error on the beta. You can draw from that distribution and then calculate a prediction for each draw of the distribution, and then express the variation in the prediction across those draws from the distribution of the betas. That usually is not done, although it should be. The third source is quite rare to see someone actually calculate the source of uncertainty, and that is how the analyst's choice of the model and the tuning parameters influence the predictions. This one in business, it's quite rare to see this one calculated. But when you put these three together, the error bars on any prediction tend to span the entire range of the feasible values. And so we often ignore the uncertainty in the predictions. It doesn't mean it's not a useful exercise. It's still a valuable exercise to do, but it's not always honestly presented. It's usually not honestly presented. It's usually presented as if the point prediction is not stochastic or doesn't have variance in it. It always has variance. And my final comment is that part of the reason predictions can be misinterpreted is that it's hard for humans to interpret probabilities. Like if you see the number 92% and you think, oh, that's definitely going to happen, that would be a very normal interpretation. But really all that means is 1 out of every 12 cases, it won't happen. 11 out of 12 it will, 1 out of 12 it won't. So you shouldn't be surprised when a 92% prediction precedes something that doesn't happen. Because that's just saying, how often is that not going to happen? 1 out of 12, it's not going to happen. But having said all that, prediction is really, really popular. Did anybody here read their horoscope this week? Me too. Not really, but, what about, locks of the week, or anybody here, any guarantees or predictions about who's gonna win a game that might be happening starting at 5:30 today? Yeah. Yeah, so that's our general comments on predictive analytics. Next up, we're going to talk about market size and how we calculate market size, how we estimate it. If you start a company and you need funding for your company and you meet with an investor to sell a piece of your company in exchange for funding, oftentimes that investor's first question is going to be, how big is your market? And the reason they're going to start by asking how big is your market is twofold. Many investors, they specialize in markets of particular sizes. One angel investor might primarily invest into $100 million markets. Another angel investor might primarily invest into $100 billion markets. So the quickest way to cut through whether they should be talking to you or not is to see if your market size estimate is within their range of specialty. So that's the first reason that they'll start with that question. The second reason they'll start with that question. Anybody know?
They want to know if the business idea is profitable or not.
Well, the market opportunity is, that's if you were to capture the entire market, that would be your that would indicate your potential revenue, which then could indicate your potential profit. Of course, the value proposition, your cost structure, there's many more things that would go into a profitability prediction. So obviously they're going to care about that a great deal, but that isn't why I would say they start with that question. If it was, they'd start by saying, what's your predicted profit margin?
Is it more like a growth ceiling?
Well, the market size will bound the potential growth.
Is it feasibility of maintaining that market share?
It's not. No, it's actually going to be pretty distant from both of these ideas. Any other guesses? So would it surprise you if I said that there's a lot of scam artists in the investment markets? Yeah, attracting. Well, we saw the Batteru boost a couple of weeks ago, right? That was a real scam that raised hundreds of thousands of dollars on a crowdfunding site. Yeah, there's scammers all over the place. So by asking you what's your market size, if you tell me a number that surprises me at all, I can say, oh, how did you come to that? Let's dig in. Let's see what assumptions you made. Let's see how hard you've actually been paying attention to this. Let's see how careful you are. Let's see how sensitive that estimate is to various assumptions that go into it. Let me see if I can trust you. So the three primary ways that we estimate market size are called top-down, bottom-up, or analyst estimates. Go ahead.
Just a quick question. Or when they ask these types of questions, do they mean your current market share or your predicted market share throughout the quarter or whatever they want?
Market size. So we're going to define it as the number of customers who experience the core need. And we could measure it in terms of customers, in terms of total volume, total units, or total revenue. So that's what we're looking to estimate with these three approaches. We talked back in week 2 about how customer needs were the best way to segment markets. Although it's often challenging to measure customer needs directly at scale. We can look for proxies for customer needs. And those proxies may be more measurable, but they may be indirect indicators. So when we think about counting the number of people who experience a core need, that can be highly error prone. We may be able to do it through surveys or by finding substitutable products that address a similar core need and counting their sales. Which is sort of the idea of the second approach, the bottom-up approach. So the counting market size according to how many people have paid to address their core need in the past is going to enable us to estimate served available market. And the difference between total addressable market and served available will be the number of people who experience the need, but have not previously paid to solve the need. So that's going to be called the unserved market. Now, in addition to these two approaches that we would usually perform ourselves, we can typically find paid analysts who sell market size estimates. And none of these approaches are perfect. They all have their blind spots. And they're not very complicated. Once you get a feel for it, you'll see pretty quickly that the assumptions that go into it are really, really important. And that's where you spend most of your time, just like with EVC a few weeks ago. The math, the procedure to estimate market size is straightforward. But getting the inputs right is really the key to getting a defensible, reasonable number. So we're gonna go, yeah, go ahead.
When it comes to getting those assumptions, like how would like a startup or someone just starting out in that industry get those? Because you wouldn't be comparable to a competitor because they're already very, very well established. So how would you like start?
Remember, the market size is the category. It's not at the product or the individual company level. And so we're looking at the opportunity for the whole category. So predicting your own market share for something that you're thinking about offering, there's a number of ways to go about that, but this is even before you have something to offer. You don't need to offer something in order to estimate a market size.
Like with those assumptions, take into account like the existence of like other companies in that market already. So like I guess I'm asking, like for like unserved, you know, like how would that play into your assumptions?
Okay, so to get served available market, we're basically going to be looking to sum up the market shares of the companies that are already in the market. And then if we're going to be seeking to differentiate ourselves to serve an unserved segment, then we're going to care a great deal about the number of unserved. Or if we think that we can beat out one of the existing incumbents, we might just primarily focus on the served available market with the idea that we'll be taking that company's market share. So we'll go through a quick case study. By the way, you guys have been doing a great job of speaking up. I'd like to run an experiment today. I'm going to commit. I'm not going to call on anyone. So if you have something to say, just tell me. Just don't let me slow you down by waiting for recognition or permission to jump in. This is your classroom.
How do you triangulate TAM, SAM, as well as external analysts, especially when they disagree in the same market?
Yeah, they won't always agree. They'll typically disagree because unserved will distinguish TAM from SAM. Analyst estimates will often rely on inputs that you don't have access to. And so the question is, how much do they disagree? And then how much do TAM and SAM depend on the assumptions that you put into them?
Like why do people ask for like market size to verify if it's a fraud or it's a scam? Like, is it because they think that market size is easier to verify, or is it market size than scammer? It's harder to lie out market size.
So many new companies get asked this question. What's the size of your market? There is no correct answer. The answer will never be knowable. We have some standard ways to answer it, which depend heavily on the assumptions that we put into them. And by walking through how a founder is calculating their market size estimate, you can observe how optimistic or pessimistic are they. You can get a sense of how much effort they put into this topic, where they're getting their numbers from. And as an investor, if you've done this a bunch of times before, it can give you a first order approximation of how reliable does this person seem to be. And for a scammer, an unknowable number is a tempting target to overestimate. And so walking through that process can help you identify when that is happening. So we're going to go through a quick case study. Suppose I have an idea for a new kind of mattress. And actually, I saw this product like 12 years ago. It didn't succeed, but I thought it was so cool. It was a mattress where there was like a hole cut out so that if you were lying together with someone, like spooning or cuddling or something, there would be space for the big spoon's arm underneath the level of the mattress so that the blood circulation wouldn't get cut off. So let's say that's our product that we have in mind. So we want to estimate the size of the market for mattresses in the US. And we're not going to try to get this right. We're going to illustrate a simple process to show how dependent the answer is on assumptions. And so I'm gonna make an assumption that TAM is approximately equal to SAM, because I think that the number of people who want a mattress and don't have one is within a rounding error of 0. It's not exactly 0. There will be a few people who want one and don't have one, but it's going to be a very small fraction of the market. Most of the market has purchased a mattress at this point. Another question that I'm going to have to make an assumption about is how often do people replace their mattress? And I know that some people, they move a lot, and moving a mattress is really hard. And so they might replace their mattress every few years. And then other people, like maybe some relatives in my own family, they haven't replaced their mattress in a generation. So I know there's a lot of heterogeneity in that, but I've seen some survey evidence that suggested on average it was around every 7 years. So based on that, I have 340 million people buying mattresses every 7 years. Annually, that's just under 50 million mattresses a year. Now, if I really want to fine tune this a little bit, I would say, even though I think the number of unserved mattress customers is a rounding error of 0, what I think might be a significant fraction that I've missed so far. Can anybody tell me what might be missing from this calculation so far?
I feel like if you're doing like a very niche mattress, like your example there, like there's maybe half the market, like that's gonna be like adult couples that have like that problem, you know, like not that many people I think are gonna go out of their way to buy a mattress with a hole in it. Like it sounds good in theory, but like, you know, how many people are actually gonna go do that?
Okay, I'm really glad you brought that up. So I think there's kind of a misunderstanding in your premise. So the core need defines the market. And so the core need here is I need something to sleep on at night. Now, my particular mattress that I'm proposing to sell, the snuggle mattress or whatever you want to call it, that is a feature which can offer a benefit for a segment of customers that might value that benefit, but that's not a core need. So I'm not trying to size the market for a feature. I'm trying to size the market for the core need.
I think what you're missing out is that like your product is very like heterogeneous. It's like very niche, right? It's kind of designed for couples, specifically for spooning. But what if I'm single and alone? I just want a mattress for myself. That's really nice as well.
So, okay, I think this is the same underlying premise to your question, which to me is a misunderstanding. The market size estimate is not specific to a product. This is a general agreement. The market size estimate is specific to a customer core need that makes them go shopping for a type of product.
Is your market size overestimated because typically mattresses are shared by more than one person, so you could be overestimating by a factor of this different percent?
That's a great point. If I assume there's one mattress for every person in the US, I ignored the number of couples who sleep together on a single mattress. Now there's a countervailing point. So according to that point, I may have overestimated my market size.
There's also a lot of people that have guest bedrooms and stuff in their houses that like have 4-bedroom houses that with empty beds in it, so it's probably not gonna fully even out, but there is that aspect.
Yeah, so that I think would be the primary argument why I may have underestimated market size. And not just guest bedrooms, but hotels or even second homes, which may even have multiple bedrooms. There's a lot of beds that don't get slept on a regular basis. So according to those two reasons, which could push this number up or down depending on which one dominates the other, I may have dramatically misestimated this market size.
I'm at a certain page. New Jersey, everybody uses. Sorry, I'll go for
Okay, this is a really common confusion. It's the third time it's coming up. The market size estimate, okay, by definition, a market is going to be the number of people who might pay to address the core need in a given time period. So this is not specific to what we are selling. We're going to calculate this before we even finalize what we're selling. So
Is there potentially a misunderstanding of how often people maybe they buy in bulk, and will buy all at once, and so suddenly some years there might be more sales, some years there's less than the average.
So what I hear you say is that this 7 years on average, this might be a big assumption. And there can be fluctuations in the market size, and that's almost like an important second order consideration. Is the market growing or is it shrinking, right? So as in the US, the population is aging, but is the population size growing overall or shrinking overall? And how might this replacement cycle timing be changing in recent years? That would be an interesting deeper dive to make this more accurate. Okay, by the way, let's go look at an analyst estimate of a market size. So I've been teaching this little example for like 8 years, and this company, Grandview Research, has been offering mattress market size estimates in all of those 8 years. So how much do you think they're going to charge?
For the reporting stuff.
Oh, you're close. Why did you say 6,000?
I've done something similar to this, and I wanted more information. And when I saw how much it cost, I was like, nah.
Yeah. Yeah. So between 4,000 and 7,000, depending on how many people we want to have access to this report. And the main reason, this is common. So you want to buy a market size estimate, you're probably looking at more than 1,000 and less than 20,000 in most cases. And the main reason for this is that some of the most common new product launches occur within really large corporations. So big companies launch a bunch of new products. And most of those products don't succeed. But there are often internal incentive misalignments. If you're working on a new product for a big corporation like a Procter & Gamble or a Unilever or a Casper mattress, if you're working to develop that product, do you want to launch it? Yeah, you're going to get a lot more out of saying on your resume, I developed, led, and launched this new product, then if you say, I developed this new product and then calculated it would become unprofitable to launch, and therefore I killed the new product before launch. That would be admirably honest. I have rarely seen that. But that'd be really cool if that had happened, but it doesn't tend to happen. Usually people, managers who develop the products strongly believe in them and they want to launch it. Even if they think it might not work, they want to launch it and make it work. And so they have an incentive to overestimate the market size. This happens a lot within companies. I worked on this problem for P&G. And these external estimates can help offer sort of a more neutral referee on what is the actual size of the market that we're using to forecast the profitability after launch.
How are these reports, I guess, gathered up? How are they, yeah, how do they cover the entire market?
It'll depend on the category. There's not a single answer for that, but it'll generally be either top down or bottom up. And then what type of data are available for those purposes? That'll depend on the category. A lot of times there'll be good syndicated data. Sometimes there won't be. There's kind of a big exception to what I just said, which is in the health insurance or the healthcare industry, where you get primary doctors who are able to estimate the prevalence of particular conditions really well. And then insurance codes can enable the counting of sort of available market within certain conditions really accurately. Okay. Market sizes are snapshots in time. For most markets, they change. And how many of you guys have taken 127? With just one hand. Two, okay. Estimated my 127 mark. But I guess 127 I've heard focuses a lot on this pattern. But I think the treatment here will be significantly different. We can look at sales and we can look at installed base. So sales often follows a rising and then falling pattern as the market matures. And we often divide it up into multiple stages. The first stage, the sales rate is rising. The second stage, it accelerates further. The third stage, it turns concave after being convex for a bit. And then you're starting to saturate and you're getting into maturity and then decline in the final phase. We can also think about this as the cumulative adoption rate within the market. And that's what this yellow curve indicates, which is often called the diffusion curve. So sales will often run this funky Gaussian pattern over time, and that leads to a sigmoid diffusion curve. Sometimes we have what's called a dip in between the early adopters and the early majority. And it's often believed that the factors that motivate the innovators and the early adopters to buy are not the same as the factors that motivate the early majority. And so when sales starts to fall off after a period of rapid growth, the question is whether the fall off is temporary or whether it's just, and if it's temporary, that means it's going to resume at some point, or whether it's actually, oh no, we've hit the end of our cycle. So here's some pretty good evidence for diffusion curves looking like sigmoids. The scale of this evidence kind of blows me away. It's 100 years of durable goods technology in the US. And a couple of these, you can see something, I don't want to use the 1940 to 1945 period as evidence of anything. But You can see something like the air conditioning curve. You can see something like a dip where growth slowed down a great deal before picking up and then becoming very, very rapid. Or here, this is the car. You can see that car sales had a local maximum in the mid 1920s before starting to dip and then not picking back up again until after World War II. So the S-curve, it's obviously not universal, but if you kind of squint, it looks like multiple S-curves at multiple rates of diffusion. And there are some pretty common claims that recently diffusion curves have been getting steeper, that diffusion has been speeding up recently. And this graph starts to show it even before social media became really a thing. Like Facebook was invented in 2005. There were a couple of social networks before that, but they didn't have anywhere near the scale. YouTube, I think, came out in 2006. So even before social media, we had diffusion curves speeding up, and then social media, I think, has likely further accelerated diffusion.
Also some service industries instead of goods and products, say service and buildings, doctor, advisors.
Yeah, in principle, there's nothing that would restrict this to durable goods.
Is it known why the reason the diffusion curve is steeper? And like obviously social media, like we know that, but like VCR and stuff like that. Like why do you think different altitudes were talking faster?
I don't think we have solid evidence. The most persuasive theory I've heard is television really facilitated diffusion a lot. And especially after the 1980s, more and more households had access to cable television. So there was really a large amount of television programming starting in the 1990s. Would that accelerate diffusion?
Yeah.
Oh, that's an interesting theory. I hadn't thought of that. I am loving this with you guys saying what you think when you think it. This is great. I'm having a great time.
Is there also been an element of production just being more efficient, so prices were brought down so much faster than previously? Lifetime of a product basically was also squashed.
So certainly some products have become much less durable in modern times. And relative to income, a lot of products have become cheaper as well. How often does the cheaper product also last less time? That might be a general phenomenon. Hold that thought, we're going to come back to it. We can also see evidence in accelerating diffusion. If we look at the fastest diffusing products, they keep getting faster and faster. And by this measure, it's time to reach 100 million users. And digital products and services, apps, they have at least the potential to diffuse incredibly quickly, right? If you can go to an app store or a Play Store and download it to a device. So ChatGPT getting to 100 million users in less than 2 months was really staggering to people who have been looking at data like this for a long time. Of course, these are very much not randomly selected products. These are extremely successful products. Most products are not successful. Let me show you an example of that. This data was reported by the Department of Agriculture. This was the number of new products introduced into retail channels, grocery and drug and mass retailers, split by food and beverage products or non-food products like toothpaste or deodorant or bleach. And on average, across the final 10 years that the USDA reported these data, we were seeing around 35 to 40,000 new CPG products introduced every year. And in the data that I've looked at in my research, over 90% of those products had failed completely within 6 months. Where failed completely means sales revenue gone all the way to zero. And they're mostly introduced by large conglomerates, like your P&Gs, your Unilevers, your Kimberly-Clarks, who are introducing thousands of new products per year. And so you might say, well, if they're introducing thousands, they should be more successful on average. But they're not more successful on average. And a lot of that is the internal misalignments where managers are trying to launch the products that they've developed.
Or it's also because it's launched by these large conglomerates. For that, a failure is not like as big of a hit as it would be to like an individual company, and the reward is a lot higher compared to the risk.
Each individual failed launch may be relatively minor, but collectively the failed launches are the largest item on their cost sheet.
All those products are also free, so that also means it's a lot easier for people to adopt them than I imagine for others.
So these,
In the previous slide, sorry, but when we look at the tech, the apps, how like.
a lot of those,
et cetera.
well, I don't think they're,
So even if people bought them later, it feels they kind of have like a gateway, but because there's a free version, I think they use that in the big version to test the product before they create these versions.
yeah, so what I hear you saying is that the final 5 products listed here at least, they charge attentional prices rather than pecuniary prices. I wouldn't agree that they're free. If you want to, maybe you haven't gotten ads in your chat GPT yet, they've started serving them.
I'd rather, yeah, no upfront cost for that.
Yeah. Yeah, very easy to acquire, for sure. So if you are ever going to start a company, or if you're ever going to be an investor in the future, you should start playing a really fun game right now called Will It Succeed? This is a notoriously difficult forecasting problem. We have thousands of new products launched every year. Most of those new products, the launch is costly, so it would only happen if the launchers truly believe that the new product addresses a real pain point. Most new products you see launched address a real pain point. And that is by itself not nearly sufficient for success. So I put this slide together 2 years ago. We'll see how this goes. Has anybody heard of Bark Air? Do you have a dog?
I do have a dog.
Yeah.
I have 2.
Do you fly with them?
No, but I wanted to, and normally with like traditional airlines, because one of them is a big dog, you have to she'd have to go in the cargo, and so it's like really scary, and she also has a lot of anxiety, so we just don't fly with her. But like a lot of my family lives all over the world, so then it's just kind of tough because, and we have to get a dog sitter, like my relative that can take her. So we definitely.
I've never flown with Draymond, but if I did, I would look at Bark Air first. It's designed around the idea of making it easy for people to fly with their dogs. This Y brush, does anybody have a Y brush? No. The idea is you just put all your teeth into your toothbrush at once and it vibrates around and you can finish brushing your upper teeth in like 10 seconds. Or do your lower teeth in 10 seconds. You can save like 90 seconds a day.
$80? That's 80.
90 seconds a day. I mean, add that up over a year. You can watch like an episode of Flappy. This is a cat door that claims to recognize dead prey in your cat's mouth and then lock the cat door so the cat can't bring in the dead bird or the dead mouse. Can you imagine being that machine learning engineer? I've got good news. We're going to train to recognize cats, but we're also going to train to recognize dead animals. That's, And then there's been a few of these. This is a bike that you can ride on the water. All right, so what do you think? Will it succeed? Is Bark Air going to succeed? Maybe 40%. Is the Y brush going to succeed? 20%. Is Flappy going to succeed? 8%. Is the SL3 going to succeed? Oh, like 60%. Interesting. You're all very optimistic. I checked it this morning. Bark Air, it's not going well. They're around 100 million in revenue, but they seem to be in the process of contracting. The Y-Brush, they're facing strong competition. It doesn't look like they're currently in the market. Flappy never launched or hasn't launched yet. Maybe it'll launch in the future. It's been in development for 5 years, and now they have 3 new competitors that have all gone through crowdfunding rounds and may enter in the future. I didn't realize this would be such a concentrated market. And the SL3, yeah, this is dead, but there's a bunch of competing devices that offer similar value proposition. So this is really, really hard to predict empirically. So that's why if you want to get good at this, you should start practicing it now before you join the wrong startup or start the wrong startup. So that's where Frank Bass comes in. Frank Bass was a professor at the university, first at MIT and then at the University of Texas at Dallas. And this was probably, if you go all time, maybe the most used quantitative marketing framework before Conjoint. It remains widely used, although the version that we're going to look at is much simpler than most of the more sophisticated versions that are currently in use today. How many of you guys read the paper before class? Okay, fewer than believe the Y-brush will make it. Okay, I'll try to teach it to you. If you don't get it, there's a reading that would help you. So we're gonna have a market size estimate that we're gonna assume that we calculated through one of the approaches that we talked about earlier. So we're actually gonna assume that we know this in the script, but it's also possible to estimate this within the framework. We're gonna have a bunch of time periods, which we're gonna index with little t. We're gonna have an installed base that's a cumulative proportion of the market that has adopted. And that's gonna be denoted capital A, and that'll change over time along with in that S-curve shape that we talked about. The change in the installed base with time is going to be the number of sales, the number of new adopters in each individual time period. In our script, we're going to call this N. And then we'll use an identity, which is simply the remaining unserved market, is the difference between the total market size and the installed base up until this point. And Bass proposed that the annual sales depended on the remaining unserved market in 2 ways. So that here on the left, we have annual sales. On the right, the first term is what we call the number of innovators adopting in each period. And the idea of an innovator is someone who would buy a new technology, even if they had not been exposed to someone else using the new technology. So they are sort of independent deciders who figure out which products are good for them to buy. And Bass assumed that there would be a constant fraction P of innovators in the unserved market in each time period. So we'll get sales from the innovators through this first term, and then we'll get sales through the imitators in this second term. So Q is going to be a parameter that we try to estimate, as is P. Q is going to be the proportion of imitators who haven't purchased yet. That'll be scaled by the size of the unserved market, R. And it'll also be scaled by the proportion of the market that has previously adopted. That's A over M. And the idea is when a larger proportion of the market has adopted, more unserved consumers have seen adopters using the product. And therefore, the number of imitators, potential imitators exposed to that is going to be R times A over M.
I was wondering how does this model like actually expanding these cases also very.
So the market size, you'll notice, is not written as a function of time. And the implicit assumption here is that the number of people who have the need is not going to be changing over time. But if this were changing over time, it would be a pretty straightforward modification to the model. I think you'll see how that would work once we get into our script. But if you don't, then let's bring it back and get into that. Sound good?
P and Q in this case correlated. Like if we were just to map the P term, it would have a higher coefficient, but since we're including Q for the sake of including imitation and understanding that we're influenced by others adopting it, would they relatively just be correlated for the sake of more people who are choosing to innovate and buy first? Would that influence those willing to imitate, kind of like celebrities endorsing a product and then people buying it after they see the celebrity have it?
Okay, so the narrow answer to your question is that the parameters P and Q are not going to be assumed to be correlated. But what I hear you saying is that the number of sales to innovators and the number of sales to imitators probably will be correlated. And the fact that the term R enters into both of those two sources of sales, I think proves your intuition that these two will be correlated. The more innovators who buy, the more imitators will see them. And so these two terms, when you plot them in the data over time, they will be positively correlated. Okay, now when you equate a variable such as A to its own derivative, we call that a differential equation. I know most of you probably haven't taken that math class on differential equations. It's its own branch of mathematics. It's very interesting, but you don't have to know anything about it. If you will take my word that this differential equation from the Bass model has an analytic solution that looks like this. So if that sounds like a good time, I hope you have a lot of fun with that, but for the rest of us, what we care about is what is P, what is Q, and what can this model do for us? And in this context, we care about prediction. So we're going to primarily evaluate this model according to its ability to make accurate predictions. Now, the original way to estimate this model was called nonlinear least squares. You know what ordinary least squares is. Nonlinear least squares, what you do is for a guess of the parameters, in this case, P and Q, you use data and parameters to calculate the left-hand side and the right-hand side of your regression equation. You take the difference and you square it, and you add that up over observations. That's your objective function. And then you search over PQ space to minimize that total sum of squares. The main difference between nonlinear least squares and least squares is that we don't get a closed form solution on the best parameter estimate because it's nonlinear, but we can calculate it numerically. And that's one of the ways that we'll estimate this model in the script. The other way that we're going to estimate the model is we're going to use that identity that I mentioned earlier, that the installed base plus the remaining market R equals the market size. And we're gonna sub in for R in this original equation. Then we can rearrange terms doing a little bit of algebra. And then we can label each of these coefficients on an intercept on A and on A squared as beta 0, beta 1, and beta 2. And then essentially what we're doing is we're regressing sales as the dependent variable on a quadratic and installed base. And then we can just use linear least squares or ordinary least squares. And if we want to, once we have estimates for beta 0, beta 1, and beta 2, we can recover the P, Q, and M that are consistent with those estimates. But we're not going to go to that trouble here because our main focus is on how well does the model predict. So I just gave you two estimators for the same model. It's worth a brief digression. Some models have one estimator, some models have many estimators, and some models have no estimators. And in theory, you might think that every estimator is going to find the same estimates. But in practice, that's often not how it turns out. Some estimators may be better than others. They may require different assumptions than others. Why do the estimates depend on the estimator? It depends on a lot of choices that we make in the process of estimating, such as how precise is the numerical system in our computer? Is it base 32, base 64, or what is the precision of the matrix inversion algorithm that we use? So, what's the numerical search function that we use to find the best set of estimates to minimize our loss function? So we're gonna, in our script, we're gonna compare across both estimators in seeing which one is estimating better, and that'll help to illustrate a few generalizable points. I took this out of the FAST paper. In this first one, he's retrodicting sales of home freezers. And this was like magic to people who had never previously had a system to predict what future home freezer sales would be. Although you gotta say, when you look at this, every single prediction was wrong. Oh. Yeah, depending what we mean by right, but yeah, this one right here is pretty close. And I think in general, like I think that's generally applicable to predictive analytics. You can't expect it to be accurate, but the process of making the prediction can really help you to think about, you know, how to interpret the prediction and what you might do depending on what will happen. So it's a valuable exercise even though it's usually wrong. You know what, I think right now is probably a really good time to take a 10-minute break, and then we're gonna jump into our script. And after the script, we'll come back and we'll go through more explanations for diffusion curves and customer lifetime value. So we'll resume at 3:15.
No worries. I think run really well, like I think. And 68 is we have how many medals and APS is there. Last year, my last year, I was trying to score. We're so like not making something.
Yeah, don't need any. Yeah, stop.
Yeah. Yes. That's so cool. That's so. Well, you can. Yeah. Exactly. You do that shit. No. Next week. The translation. You do it too. Yeah. Show me that, bro. Okay. Bro, got upgraded. I know. That's good. Oh, that's you talking about. We asked you. He's like, oh yeah. Like, bro. Like, they should go out to our do it. She's like, oh, I just wait some time. Like, I get like, she's like, oh, you have to really push this break. Yeah. Yeah.
I already went on Monday, so questions are need.
Oh, you want to get money,
Yeah, thank you.
Look into last days.
Yeah, here. Yeah. Actually.
No, it's like Joe Meyer. It didn't work out. Not being on.
With the big,
Like right after super.
I know, right? Yeah, that's true.
Yeah, there's a lot of stuff for us here. But yeah.
Nice.
You done, you can do something else here soon.
Yeah. So.
So good.
Very fast. I've already gone through 3 batteries. Bro, like here's the weird. It only fucking helped. Like, you will get through. Like when we get those five, it's like I would just throw it to like my problem. Like they go there and so I guess it could be. You guys will find out. I have my job.
Okay, thanks for coming back. So in this script, what we're going to do is we're going to simulate some data. Then we're gonna use known values for P and Q in order to simulate that data. Then we're gonna pretend like we didn't know those values, and then we're gonna use our 2 best model estimators to estimate those values based on different cuts of the time periods available. And we'll compare the estimators on in-sample fit to the training data and also out of sample fit to the non-training data. So invite you to step through with me, or I'll give you the voiceover as we go here. As always, please interrupt me with any thoughts or comments or questions. So we're going to start from a market size of 100. Going to assume P to be 0.02 and Q to be 0.2. In general, estimates of Q tend to be substantially larger than estimates of P. And we're going to use a 40-period time horizon. And we're going to simulate period by period sales, capital N. Installed base is the cumulative sales up until each point in time. Remaining market is just M minus the installed base, so 100 minus A. And then we'll use a little vector T to index time periods from 1 to 40. And then we're gonna seed those 4 vectors with initial values. We're gonna go from period 2 up to 40. And right here is where we use the BAS model to fill in the number of sales in each time period. And then we'll increment the installed base and decrement the remaining market according to that number of sales that the model predicts. And we can take a look at our simulated data. And our period by period sales has that Gaussian distribution that we saw before. And we can also look at the overall diffusion. That's the red dots. That's the sigmoid, the S curve. And the remaining market is following in a parallel version of the same S curve. And so the period by period sales is actually pretty small compared to the overall accumulated sales or the remaining market in the early part of the time period. Now, this process that we're going to go through, this is a very general process. It's used in many, many different settings where when we want to estimate a model using real data, before we apply the model to the real data, we will often use the theoretical model to simulate data from known parameters, then apply the estimator to the simulated data to see how well the model recovers the known parameters that generated the simulations. It will help us to understand the properties of the estimator, and it will also check our code to see if it's working properly. So the first way we're going to estimate the BAS model is using that linear regression with an intercept, installed base, and installed base squared. And so that's what we're doing here on row 79. We're using the full simulated data sample, and we can summarize that linear model. What we see is that we get a very small intercept, nearly 0, and sales is increasing and installed base at a decreasing rate. So we get like this convex function, or concave, excuse me, I said that backwards. Concave function in the black dots. Our R square is 98.7%. That sounds pretty good. Testifies to how flexible the linear model is in fitting any type of curve. And we can plot the model's fitted values against the simulated data. And the linear estimator has a hard time getting this jump. It interpolates it early on. And that interpolation causes it to sort of misestimate the shape to some degree. It overshoots before the peak, and then it undershoots after the peak. But overall, it looks pretty good, right? Okay, the second way we're going to estimate this model is the nonlinear least squares estimator. So we're going to write a function called BAS SSE, stands for sum of square errors, which will calculate the objective function for the nonlinear least squares estimator. And it's going to take in a 2-dimensional vector P and Q, which we're going to search over. For any given guess of P and Q, it's also going to take in data on sales, installed base, and market size. We're going to separate out PQ into P and Q. We're going to use the BAS model. This is the same one we saw in the slides to calculate predicted sales in each period as a function of P, Q, A, M, and N. And then we're going to calculate our error term as the difference between observed and predicted sales, square it, sum over observations, and that's going to be our objective function value. Any questions on that? So in order to use that objective function BAS SSE to estimate P and Q, we're gonna start, it doesn't matter too much where we start from, but we're gonna start from 0.1, 0.1. And then we're gonna run a numeric optimizer, which we're gonna tell it to start from those guesses of P and Q, then search over PQ space to find the combination of P and Q that minimize our objective function. And then we're gonna give it the simulated data. So that process is pretty fast in this context because it's a small problem, only 2 dimensions, only 40 observations. And it gave us back a set of parameter estimates. That's in PAR, that stands for parameters. The value is the objective function value at those optimized parameters. And then the other stuff is properties of the numerical optimization that we're not going to get into today. So the parameters it estimated are 0.009 for P and 0.23 for Q. Do you remember what those known values were that we used to simulate the data? Yeah, 0.02 and 0.2. So it looks like it underestimated P by a bit and it overestimated Q by a little bit. So next up, we're going to use those P and Q estimates to retrodict the sales in the training data. And that's what this function on row 127 is doing. So we're going to pass in the parameters. We're going to pass in the time period over which we want to calculate our predictions. And then we're going to predict sales in every period over that time horizon. And we're going to overlay our sales predictions on top of our linear estimator sales predictions and the actual simulated data. So the training data are in black. The green dots from the linear estimator are still here. And the purple dots from the nonlinear estimator are now present as well. So it looks like the nonlinear estimator has also interpolated this big jump in the beginning of the data simulating period. And we get maybe a little bit of divergence between purple and green up here near the peak, and a little bit of divergence down here toward the end. But in general, the 2 estimators produced very similar predictions when we give it the full training data. And we can calculate the R-square of the nonlinear estimator, and it comes out to be almost the same as the linear model R-square, just a little bit less. So 98.6, whereas the previous was 98.7. So very, very close in sample fit. Do you think we've reached any high-level conclusions by the comparison at this point?
Based on process. Like a model that's 100% accurate, just being something that's as successful.
Yeah, we usually won't get to 100. If we get to 100% accuracy, something has gone wrong. It's usually, yeah, but we're looking for the best available alternative, and in this case, we only have 2 alternatives. Does anybody, does it look like these 2 models perform equally well to you?
I feel like green does slightly better. 'Cause it's just closer.
Yeah, slightly better. slightly higher R squared.
Maybe it's the kind of prediction you're looking for, you want a more conservative estimate, maybe go for something else. If you want maybe more accurate, maybe gonna be more generous estimate, because it depending on the year, you maybe prefer purple versus black. Green.
Okay, let's think back to I think it was week 5. We looked across heterogeneity specifications, and we talked about what's the single most important factor when you evaluate a model. There's many things, many criteria you could use to evaluate a model. It's usually use multiple criteria, but what's the single most important model evaluation criterion? That's a good guess, but it's not past behavior. Okay, you're giving me a good reason to ask this on quiz 2. Nobody knows?
Past purchase.
Good guess, it's not past purchases. Okay, the question is, what's the single most important criterion that you use to evaluate a model?
How good the data is.
That's a good guess, but that's gonna apply to all the models in this case, all the estimators. Okay, it's 3 weeks ago. It's one of the,
Projected sales. Maybe sales,
elaborate on that.
an assumption on like how much sales you're gonna.
It's a good guess, but I don't think you're getting there. Yeah, nice try. Why do we estimate models?
Based on how close it is to like the real world, what actually happens.
Uh,
How close the estimator was versus what actually happened.
that's a good guess, but I don't think that's it. Why do we estimate models?
Because we don't really have any feature data either, and that's what we're trying to estimate.
Okay, I think what I'm hearing you say is that the purpose of these models are to predict,
Forecast.
to forecast. And you're applying the general answer in this context, which is valuable. You're the first one to do so. But the general answer is, why do we estimate models? Because we want to do things. Maybe we want to understand something that happened in the past, or maybe we want to predict something that will happen in the future, or maybe we want to make a decision. In this case, we want to predict something that will happen in the future. And that is why the single most important criterion we should use to evaluate any model is its performance on the reason that we're estimating it. If we want to predict something, predictive ability is the most important criterion. Now, the reason I don't think we can reach any informative conclusion from what we've seen so far is that we've given both estimators all of the training data. We've only looked at in-sample fit. We care about predicting after the sample. So that's what we're going to do next. And if you're confused, this is a great time to ask a question, because it is confusing. I don't think this is simple.
I was wondering, once you find like a good predictive model, how far into the future can you utilize it?
Yeah, unfortunately, any model can break if the data generating process shifts in a significant way. But absent such a regime shift, you can look backward and see how stable the retrodictions remain accurate in past by withholding some of the data in the existing training data. So that can be an empirical question that we test.
For most, like like criteria of how well does this predict the data we're using, like data that is within that set, like we withhold some of that data. So, like how are you able to evaluate that with like future data?
Yeah, that's exactly what we're gonna do right now. So rather than giving both estimators all 40 periods, which leaves them nothing to predict after the training sample, we're gonna shorten the training period horizon. And then so therefore we'll use less training data to estimate the models. And then we'll use those models to predict what would happen after the training period horizon. And that's where we're gonna evaluate the two estimators, to see which one generalizes to the non-training data better, given what we care about. Okay, so in this case, we're gonna restrict our training period to 12, which is right around where this peak, just before the peak is gonna happen. So sales are starting to slow down. And short sim is gonna be our shortened training data. And then we're gonna estimate the models in exactly the same way, but this time using short sim rather than sim, which had the full 40 periods. And when we do that with our linear estimator, we're gonna get the same pattern on sales is increasing in A at a decreasing rate. Our R squared is gonna be 95.2% this time. Before it was 98.7, so not quite as high, but still pretty high. And we can go through the same exercise to plot the in-sample fitted values. And it looks like they have pretty similar properties to the first 12 periods as before. Although we're starting to undershoot the peak a little bit here at the end. Then we're also going to estimate the nonlinear estimator the same way, this time using short sim rather than sim. And it's kind of interesting to me. Remember, our true values for P and Q were 0.02 and 0.2. When we gave the nonlinear estimator the full sample, it got 0.009 for P. And we actually got a little closer this time when we give the model less information. And it had 0.23 for Q, and this time it has 0.216. So nonlinear estimator is not becoming less accurate. If anything, it seems to be a little bit more accurate. So we can also compare the in-sample fit and the in-sample predictions for the nonlinear estimator. And this time it's diverging a little bit from the linear estimator. And its R square is 95.0, whereas that was 90, where was it? It was here, 95.2 for the linear estimator. So again, very simple, very similar in-sample fit between the two estimators, but that's not the main thing that we care about. So that's what we're going to do next. So what I'm going to do is I'm going to create new functions which will use the estimated model along with the final value of accumulated sales for installed base A at the end of the training horizon. And then what it's going to do is for every period after period 12, it's going to use the estimated model to predict the next sales. It will then update the estimate of the install base using that prediction. And then it's going to repeat that process for every period up to 40. So we're going to make a series of iterated predictions from period 13 up to period 40. So that's with the linear estimator. And when we do that, we can plot that against the actual simulated data. And it looks like it recovers the shape really well, even though it only had the first 12 periods to train on. But it's consistently undershooting the sales. But overall, I'm not displeased with this pattern at all. It seems pretty accurate, just a little low. Now, I'm going to write a second function to go through the same process for the nonlinear estimator. And here you can recognize the BAS model formulation. And then we're going to update installed base, update remaining market. And so this will generate the same or a similar procedure to make iterative predictions after the training sample. And when we add those into our graphic, we can see that the nonlinear estimator recovers the unseen simulated data almost perfectly. And this is what we should use to select between the estimators, because this is the reason that we want to use this framework. And if we want to sum this up, we can calculate the sum of the mean square prediction error out of sample for both estimators, and they differ by 2 orders of magnitude. Now, in a way, you could say quite reasonably, this isn't really a fair fight, because the nonlinear estimator embeds the mathematical structure that we use to create the simulated data. And that's why it does so well. Linear estimator did pretty well also, just not as well. Okay, any questions on any of this before we wrap it up and move back to the discussion?
So I understand like this this model kind of like takes any data from certain periods of time, right? And we have like these testing periods, but in this class, like, are we able to make like models that take in perpetual data? So like as time moves on, like it'll like I guess automate inputs of data perpetually, so that we can get even more, I guess, like accuracy or better forecasts.
Yeah, what we would very often do, we're speaking at a pretty high level. We'll always want the most recent data and then re-estimate our model with the most recent data. An open question is how much of the older data should we keep when we estimate the model? Do we want all of the data from all time? Do we want the last couple of years? Do we want to continually roll data out as we roll new data in? And that depends on the stability of the data. So most companies will look at a training horizon, and they will often move old data out as new data comes in and then re-estimate on a regular basis. Okay, so in the competition, I'm going to ask you to change some of the fundamental parameters of that procedure. This probably won't be the hardest competition that we've had. So coming back to understanding diffusion and playing the game of will it succeed? There's a guy, an academic at the University of New Mexico. His name was Everett Rogers. He spent 40 years studying the diffusion of innovations, these S-curves. And in total, he summarized something like 5,000 published studies. And according to Rogers, there were 5 factors from the customer's perspective that predict high diffusion of new products. And that was how well it works over existing alternatives. He called that relative advantage. Compatibility, the idea is what are the switching costs that a customer has to pay if they move from one product to a new product. Complexity is the customer's confidence that they can accurately predict what the product will do or how it will work. Trialability is sort of a weird word. It means how easy is it for the customer to sample the product before they purchase. And so the easier it is to sample, the more people will get a taste, and that will inform them about whether they should buy or not. Observability is how easy is it for one customer to see whether other customers are using it. These have been widely taught and applied in practice. By far the dominant paradigm to make the prediction of will it succeed. So let's play the game. We'll go back. Relative advantage, compatibility, complexity, trialability, and observability. So let's look at the Y brush. Relative advantage. How much better is it than what exists?
Seems like it'd be a lot better. You can do stuff while you're using it. Like maybe like traveling might be easier. Sounds like good in theory.
I feel like it doesn't save me that much time in comparison to how cheap a regular toothbrush is. Right, the toothbrush will cost you maybe $5 at a pharmacy, and it doesn't take you that much longer to brush your teeth with a regular toothbrush.
Anything I have to charge as a real cost over the simple manual e-impact.
I think the market where I see this growing is like people who don't have actual motor skills to use hands, or I guess their apparatuses. So maybe like for those who can't actually brush their teeth with like common toothbrushes, right?
Interesting. I want to caution you against using cost to evaluate relative advantage. Relative advantage is more like the willingness to pay. But if we had studies quantifying how much more plaque is removed or how much time the average customer saves by using the Y brush, that would be what lets us get to a confident answer. Sounds like right now we have a lot of difference opinion on relative advantage. Our second one was compatibility. That is the switching cost to go from a regular brush to this new brush. Is this a highly compatible product or not very compatible?
It's compatible with human teeth, right?
Yeah, you don't have to get new teeth. That's true. Is there anything new that you have to get in order to use the Y brush? I'm going to assume it ships with batteries. Charger. Do I need a new charger?
I think it should ship with the charger. But then I think the complication, and I think why it's not really selling, is more because it's more so if it actually works and cleans it or not. I don't think it's a time factor. Because I think the price range is pretty similar to like electric toothbrushes that are already in the market. But then
You're jumping to the final answer, but I want to go factor by factor to illustrate how this works. So I'm mostly hearing sounds like it's very compatible. Not a lot of switching costs that we have to pay. The third one was, do you remember? Complexity. How hard is this to understand for the customer?
Not very. You put it in your mouth and you press the button. Seems like a really easy process to use.
And even because a lot of people have different like dental conditions with pets, that could be something that's complex for some people.
That's literally the reason I haven't tried this product. Is I just don't know if the shape of my teeth are gonna fit where they're. Does everybody have the same? Because I don't even think it's the same on top and bottom. It's like for.
Might have like for algebra, the bottom, like for narrow per se, and you guys have like different shapes.
And maybe they've designed it to accommodate that, but for where we are right now, that to me at least, that seems a little unclear. And we don't all have to agree. This is the point here is to illustrate the process. What about trialability? Is this thing easy to sample?
No.
Yeah, do you wanna go to Costco and like go to the sample booth and like stick the, yeah, exactly, that's gross. Yeah, it is not easily sampleable, right? You have to actually have one in order to try it.
Yeah, you can't even return it if anything, I don't think that's like.
Yeah, what about observability? If you adopt this Y brush, are other people gonna know?
Unless there's you. That's true.
Um,
Like, only you're walking out outside, like toothbrushing your mouth.
are you gonna tell them?
Yeah, I feel like the type of person that buys this definitely telling everybody.
Actually,
Let's do that.
That doesn't sound like a compliment.
I mean, I've gotten into it.
I mean, if it works really well, I guess your dentist will know that you use it. Teeth will be, I guess, cleaner, but I don't know any dentist that does recommend this product, so I don't think they will be able to tell if you use this versus just like flossing.
Yeah, okay, so these 5 factors are commonly used to make a prediction, but they are also commonly used to improve a new product before launch. And okay, let's say we're concerned, in my analysis, I'm concerned about complexity, trialability, and observability. So how can I make this thing more observable, or how can I compensate for low observability? And this is a pretty common recommendation. We'll go to dentists, we'll show them the data on relative advantage, we'll explain to them how it works, and they can reduce the complexity for the customer, leveraging their relationships if we incentivize them to sell this thing. So
It also seems like a super easy like influencer campaign, social media like type device that would like the observability way better, like this be like piece of cake in that kind of like marketing style.
yeah, probably if we have like solid data on how well it works, that can seem credible. That could even supplement that further. So this is the Rogers framework that is really popular to try to predict and improve new offerings, what we expect their success to be. As I said, this has been incredibly influential. I do think that it leaves out some really important factors that probably help to explain diffusion curves. There's nothing in it related to customer heterogeneity. And I think in general, among innovators, there's probably a shared heterogeneous preference for risk-taking or willingness to look dumb, which is not common in the mass market. It also may be that the people who have the most money have the most money to waste, and they may be most willing to try something out, even if it doesn't work out, they don't necessarily lose that much. So there are a number of individual factors that can help to explain why diffusion is nonlinear over time that's left out of that Rogers model. It also neglects things the company does, other than product design. And it's also the case that usually markets evolve after product introductions. Often products enter with new features. Production often becomes cheaper as we learn how to manufacture more effectively and more reliably. And so there's, even with that Rogers framework, there's still a lot of uncertainty. So it's still a fun game to play and a good skill to develop. But I feel like the Rogers framework kind of puts blinders on, and there's a lot more to the full story.
Looking at the model at least to give you an idea of what's going to fail, maybe not what will succeed. If it doesn't hit those 5 at least, it's probably a pretty good sign that it's not going to succeed. So it can be like a starting point.
Yeah, so usually we're going to need some data to estimate the model. So if we're introducing a product that's in a category of its own, and we have some initial sales data, we can estimate the model to predict how much more success we may have in the future. Whereas the Rogers framework is often looking before we launch this thing, we want it to succeed as much as possible. Exactly what should we launch? But they're very much yes and, it's not this one or that one. There's a practice called viral marketing. It goes back before social media. It's really taken off since social media has gotten popular. The idea is who are the most influential users, and then what should we do once we identify them? Should we give them the product? Should we pay them to promote the product? Should we pay them as a function of referred sales? That's called affiliate marketing. We don't have a lot of great evidence on this, but there was a really good paper that came out of MIT. Facebook used to have a native movie app within it, and when someone used the app to rate a movie, their friends would be notified. And these two social scientists, they randomized some of those notifications in an experiment to observe which of the notified friends would then use the same app. And they looked at the properties of the notifying friend who first used the app, and then they looked at the properties of the friends who responded between treatment and control. And their headline finding was that, yes, social influence is a real thing. Notified friends were more likely to adopt the app. That's pretty obvious. But what's less obvious is that people who tended to be more influential, they tended to be influenced less by others and vice versa. So they divided people according to influence versus susceptibility to influence. They found that older users were more influential on average, younger were more susceptible. They found women influence men more than men influence women. And they found that in this context, influencers with influential friends had the most overall influence. I really love the attitude expressed by one of the co-founders of Discord, who wasn't CEO for a long time. He stepped aside, I think it was last year. And he was asked, what is one of your worst ideas that you would just never do because it's obviously a bad idea? He said, I'm sure I have a lot of bad ideas. I just don't know which ones are bad before I try them. And then he said, when we were originally building Discord, we were a team of about 12 people. Half of us thought Discord was a bad idea. It turned out to be a good idea. I love that he didn't say which half he was in. But, bless you, I think this is kind of the right approach, is when it comes to potential innovations, even if the relative advantage is good, you just don't know what's going to succeed. It is fundamentally very difficult to predict. And trying and testing is the only way to find out. You guys are, most of you are going to be graduating this quarter, right? How many of you already got a job? It's tough right now, so congratulations if you did, that's awesome. And if you're still looking, keep your head up, you know, you only need one. You know, I think that I would encourage you to think about this market size and diffusion thing as you think about what employer makes sense for you. I had a really kind of silly experience in retrospect that it's probably going to make me sound dumb, but I'm happy to share with you if it could lead to a better decision for somebody in here. So I got to college in fall of 1994, and I got a job as a computer lab monitor. Nobody had a laptop back then, they were too expensive and they sucked. So the university provided rooms full of computers and anybody could go in and use it whenever they wanted for their homework. And I was in there like 20 hours a week. And I started using this browser, which I had never heard of before I first used it. It was Mozilla. And I was like, this browser, this web, World Wide Web, this thing is amazing. I hadn't had it at home before I got there. Most people hadn't gotten it yet. I was just blown away, and I still remember Yahoo. It was like the telephone directory of the internet. It was organized by letter, and it listed all the web pages. There was under 100 web pages. And I thought it was so cool. I started learning HTML. Later on, I learned JavaScript. And then I picked my major. And the major that I picked was called broadcasting, which means TV and radio at that time. And, you know, I think it's not too surprising that I picked that major. Mass media was incredibly influential. But what I just really don't understand is, having seen the web at a very early stage before most people, why didn't I study computers or something related to what I thought was amazing? And I think that it's a pretty common phenomenon, and I think there might even be some social pressure for you to choose a career where you might be going into something that looks very respectable, very safe, something that pays well. And that can work out for sure. But I also think that if you have a belief or a feeling that something is going to blow up, or that you think something is really cool, that is also a great reason to go into that. You know, if you have like a product or an app or a service that you think is fantastic, you should check if they're hiring. You know, it's a great early signal. Is your consumption experience about which companies might grow quickly, or which technologies might catch on in the mass market in the future, if they haven't yet. So, yeah, I found my calling eventually. I'm very happy where I'm at. But yeah, in the years between 94 and 2002, I was really kicking myself. I was like, what was I thinking? So I hope you guys are generally smarter than I was. So I'm sure you won't be subject to that. But you know, if you're making a choice between two options and your parents think one of them is better, maybe, but maybe not. I'm not calling on hands today, but you're welcome to speak.
If you are in like a similar situation where you're choosing between a career path you believe in and one that your parents believe in more, they're not the same thing. Using what we learned today in class, is there a good way to maybe test the theory as to like, oh, I want to work at this startup and I think it's gonna blow up, or this maybe company's a bad one to work at, I don't think they're gonna blow up?
That's a great question. How many of you guys have seen Google Trends data before? Okay, so I don't need to spend a ton of time on this. I think this is probably the best way to measure unserved needs. The reason this data is public, so it basically counts the share of searchers who searched a given keyword in a place and time, and search engine. So they expanded it recently to report YouTube search and Google Shopping and Google News search. Do you know why it's free? Back in the 2000s, it was pretty clear inside Google that if you searched a stock ticker symbol like Netflix is NFLX, the number of people searching the ticker symbol strongly predicted the share price movement. So they were like, oh, we could get rich on the information that we gather from people searching our search engine. But if we do, the Securities and Exchange Commission is going to come and regulate us, and we don't want to be regulated by them. So we'll just give it to everybody. And that concern just seems so quaint in 2026. It doesn't look like other information aggregators are expressing the same transparency that Google did back then. And if Google ever retires this data source, I won't be surprised at all.
What's your take on joining a startup that just got acquired by a really big corporation?
Oh, that's interesting. So isn't that the same as joining the corporation, right?
Technically, yeah, but they're still like operating independently.
So I guess it sounds like that was not an acqui-hire, right? That they're not just acquiring the startup for the talent that it's attracted previously.
Yeah, like the startup was thinking of going public, but then they decided to.
Yeah. I mean, in a best case scenario, the acquiring firm will enable the startup to scale the technology. But there's definitely a lot, like a very mixed evidence of success of that type of combination. So if the startup product is competing with one of the core products of the acquiring firm, it sounds like they're consolidating market power and they're going to be very profitable, and that'll probably be a stable place to work. Doesn't necessarily mean the startup's product will become successful, but that isn't necessarily relevant to your career decision. But if the acquiring firm is buying something outside of its area of expertise, I'm not sure I would see that as a positive.
If a corporation like acquires a startup, do you see that as like a sign that they believe like their product will work?
That's one possible reason, but there are several other possible reasons that may be completely orthogonal to that. So I think the most common motivation is this startup has some smart employees and they've impressed us as a group. Let's bring them on board. But those tend to be low acquisition prices for the purpose of talent recruitment. Okay, our final topic is called customer lifetime value, and it's a format. It's a framework that enables serious discussion and quantification of novel policies. That to me is the greatest value of customer lifetime value. It's defined as the net present value of the stream of expected future profits of continuing to serve the customer. It was developed in the 1960s by catalog retailers, companies like IKEA, LL Bean. They send like books of products out to people's addresses, and that still happens. And every time they mail out one of those books, they have to print it and ship it. And today, the cost for doing that is usually between about $4 and $8. And so their goal is to only mail the books to people who will buy things and to avoid mailing the books out to people who won't buy things. So they have to choose which households, and they have to decide how often to send out those books. It's a very versatile framework. And so as more companies have subscribed to customer databases, it's become a relatively low cost add-on to customer databases. So it's available in, I'd say, most companies, but not all of them yet. And it remains underused in many companies, in part because of the stochastic nature of CLV. So my favorite example of applying CLB to implement a new policy came out of Utah. I think it's a pretty amazing story set in an unlikely place. So in 2005, Utah had around 2,000 chronically homeless people. And chronically homeless means that they've been homeless for more than a year, or that they've been homeless multiple times within the past few years. So most people who become homeless, they get back on their feet, and it usually doesn't take them that long. It's usually between a few weeks and a few months. But a substantial minority of people, they don't get back on their feet, and then we call them chronically homeless. And those folks are really suffering, and they experience a lot of needs for public services. If they need medical care, they'll often go to the emergency room at a hospital. They make use of public services like homeless shelters, sometimes ambulances, sometimes police, sometimes courts. And Salt Lake City totaled up all of the public expenditures per chronically homeless person. And they found that they were spending over $20,000 a year on average for their chronically homeless individuals in the city. And then they compared that to what would happen if we just built apartments and gave that housing to chronically homeless people. And they calculated that to cost $8,000 per person. And so they ran a pilot program, and they said it was very successful. That after 22 months, no one who was housed who had been chronically homeless, none of them went back to live on the street. And this was published in, I think, 2013 that I'm quoting, and 2014, excuse me. And they said after a number of years, our number of chronically homeless residents had fallen by 74%. And you might not have expected like a very Republican state to be the one to pioneer the approach of building houses for homeless people, but they did based on effectively CLB statistics.
Why can't we do this in California?
Actually, this has been the predominant policy in California for most of a decade. And I don't need to go into all of the details. I don't mind doing it, but I want to make sure you don't take the wrong message from what I'm saying. I'm not saying that this program, which is called Housing First, has solved homelessness. Unfortunately, the data is very clear. That has not been the case. This has been the federal government's primary policy prescription for over a decade. I think they just dropped it last year. And the way it's been implemented in different places has been very uneven. In San Diego, we don't have land to build new housing the way they did in Salt Lake City. And so it's been implemented here using existing shelters, single occupancy hotels, and housing vouchers. Also, the metrics that were used to report the success of this program have been revised several times, and I think they're seriously questionable. I think there's some motivated reasoning in some of the public reporting that's been done. And then there's a couple of really important questions that are very controversial. One question is if someone is living on the street and if they have an addiction of some type, which is fairly common, do you require them to enter treatment for that addiction when they enter housing? Because if you do, that will strongly discourage them from entering the housing program. And so that, I don't know the answer there. And then there's also a possible question, does the existence of this program somehow change the flow of people who experience homelessness? I think you could reasonably make an argument that it does, but I don't know how to quantify the size of this as an effect there. So I'm not saying this worked, or, I think that's very hard to know. I'm also not saying it didn't work. What I am saying is that when you quantify the costs and benefits of individual customer relationships, that quantification can enable serious discussion of novel policies. So that is the real value of CLP. And I believe that's why it's used in so many companies. So we're going to go through an exercise of calculating CLV. I will put something very similar in the question bank for quiz 2, I promise. We're going to do the simple version. We could also do this in a heterogeneous way across segments, but we'll keep it homogeneous. So we're going to look at a planning horizon. This is most often going to be 3 years. And Jeff Bezos likes to say that at Amazon, they have a 7-year planning horizon, and that enables them to justify larger, longer-sighted investments than most other companies, just from an accounting decision. We're going to have a contribution margin of serving a customer in each year. We're going to have a retention probability. If we serve them this year, what's the chance they're going to come back next year? We're usually going to use past or current data to estimate margin and retention. And then we're going to have a cost of capital, the interest rate we would pay if we borrow money, and we'll use that to calculate 1 over 1 plus that rate. That'll be our discount factor. And then there's 2 primary versions of CLV. The first one, which we're going to focus on, is starting from this year, going into the future. The other one starts from year 1, going into the future. So the difference is whether the decision that we use CLV to make affects our profits and retention this year, or only starts affecting them next year. So we're going to apply this formula for a tennis club. Congratulations, you got your first job. You're running the San Diego Tennis Club. And to join the club costs $300, and that gets people the ability to rent the court. And then on average, they spend about $100 a year at the club. And so our average margin on their spending is about 60%. And in recent years, 80% of our members have rejoined every year. And if we borrow money, we pay 15% interest on that. So what is our CLV for a 1-year horizon? Need to figure out how to get a typewriter on the screen. It's kind of hard to write with a mouse. Okay, in a single year, our margin will be $360 from a member. Our CLV for a 1-year horizon is going to be our margin, which we can pull out of the summation. So that'll leave a 1 for year 0. And then if you look at the formula, you'll see that year 2 is going to have a retention probability that they're going to stay a member. I apologize for this horrific handwriting. This is a decimal right here. And we're going to discount the margin from the next year. And so if you calculate that, perfect. Thank you for doing that. So that's our CLV on a 1-year horizon. On a 2-year horizon, we're going to get the same 2 terms in the parenthesis. plus a 0.64 over a 1.15 squared. And I just committed myself to a lot of writing. Ooh, that's going slowly. Oh my, that 4. 1.15 squared. Anybody have that number? I'm going off the top of my head here. Done this a few times before. 789. I think it's 789.
Yeah, 74.
Oh, 84. Okay, thank you. Yeah, so you can repeat that, add one more sequence to get to the 3-year horizon. And you can start to see, right, from 360 to 610, that's a difference of about 250. From 610 to 784, that's a difference of 164. You can see how rapidly the current value of the future year retention profits are asymptoting towards 0. And that's why setting a really large time horizon isn't going to make a huge difference on a CLV estimate, because those distant years will be discounted heavily. Okay.
Possible for a company to have like CLV but still have high profit.
If you have a really large number of customers, yes. But the margin of serving a single customer is embedded here in the calculation. So that's probably the only way to get a high profit without a high CLV. Okay, one of the ways CLV gets used a lot, I'm going to go through a valid application of CLV and an invalid application of CLV. The valid application is in customer acquisition. So this is a really common calculation, is if we were to pay a fixed fee to acquire a certain number of customers, that will be profitable if our average cost per customer acquired is less than our CLV. So this is just a benefit versus marginal cost comparison. Now, there's 2 tricky things here. One tricky thing is that before we make the investment, we don't know how many customers we're going to acquire. Makes our average customer acquisition cost, that's uncertain ex ante. What about our CLV? Is our CLV certain or uncertain?
Uncertain.
Uncertain. Yeah, it's predictive analytic, which is inherently uncertain. It'll generally be wrong, but it may be right on average. So when we do this marginal benefit versus marginal cost comparison, with both sides being uncertain, let me tell you the extremely dumb way that most companies make this decision. Dumb's the wrong word. The simplifying approach that managers usually use. It's not dumb. I said the wrong word. It is not dumb. It's simplifying. So suppose we are considering a decision and we predict the marginal benefit and we predict the marginal cost. And it may well be the case that marginal benefit exceeds marginal cost. But they're both uncertain. So we may find out later that in fact we lost money. We're going to put in something called a fudge factor. And then we will only go forward if the marginal benefit exceeds the marginal cost times the fudge factor. And the fudge factor is usually assumed to be either 3 or 7. And please don't ask me where those numbers come from, because I don't know. I just know they're the most common ones that I've heard used in the past. So this fudge factor is like a really easy way to try to only make highly profitable bets so that we don't waste money. Because there's usually many ways to acquire customers. And even if there's one that we predict the benefit exceeds the cost, since they're both uncertain, if we invest into it, we may find out we lost money, we may get fired. We don't want to get fired. So CLV is on the benefit side of the customers acquired. Customer acquisition cost is on the cost side with the fudge factor. So a really simple application of this, suppose our same tennis club had a chance to pay $20,000 for a billboard. And you remember from last week that on average, if 1,000 people see an ad, one of them is going to purchase on average. So we could use that to predict what how the billboard's expected audience of 100,000 people in a year, how many new customers that would yield for the tennis club. So if 1 out of 1,000 buys and we reach 100,000 people, we'll get 100 new members, is our prediction. And if we are paying $20,000 for the billboard, the average customer acquisition cost would be the total cost divided by the total number of customers acquired. So 20,000 divided by 100. And that's going to be $200 per customer acquired. So if our CLV, for example, was 784, and our average customer acquisition cost of the billboard was 200, would we go forward?
Depending on the fudge factor, right?
Depending on the fudge factor. If it's 3, then this looks like a good bet. If it's 7, it's not favorable enough to spend our money here. Let's go try to find something more favorable.
You usually test both of them when you're doing more useful for the inside, or do you just choose?
The testing is often a foreign concept in this type of scenario.
Some comparable. Inside.
This is a simplifying decision-making aid. So
Wouldn't that be like counterintuitive to like profit maximizing? Because even though it's like a marginal benefit, it's a marginal cost, it's like only worth it if it's like times 7. It seems like you're kind of leaving a lot of profit on the table.
yeah, I think that's been one of the themes of this class is I think a lot of profit gets left on the table, often essentially in the interest of minimizing risk.
7 times seems like a lot.
It really depends on how many opportunities you have available and how much you don't believe them. Like, where do you get the 100,000 number? It's from the people selling the billboard, usually. Like, you might be able to verify that yourself. You could go sit in front of the billboard and count how many cars drive by in an hour or something like that. Like, you could definitely reduce the uncertainty, but it's costly to do that. And plus the advertising market is full of scams, just like the investment market is full of scams. So you do have to be cautious. Okay, that's the valid application of CLV, which is pretty common. There is also an invalid application of CLV that I want you to understand. Suppose your price is $100, you have a 50% margin. Suppose your customer retention rate is 50% and your discount rate is, or your cost of capital is 10%. If you put that into the CLV formula, you'll find a CLV of $72. Now, suppose you're considering a price increase from $100 up to $120, and you want to see how that changes your CLV. With the same formula, you would come to a CLV of $101.82. Should you raise your price? No? Yeah, that is why this is an invalid application of CLV. You cannot increase your price and believe that your retention will stay the same unless you believe that demand is perfectly inelastic. What I just showed you directly implies a demand curve that is perfectly vertical. So that's why that would be an invalid application of CLV. Of course, if you estimate demand, you could bring that estimate in to see what retention rate would correspond to a given price increase. So this is remediable, but unfortunately, this is a fairly common invalid application of CLV. So this is not what this tool is useful for. If you go back, recall, predictive analytics don't tell you what to do. This is an example of that. So CLV has become really popular over the last 20 years. A lot of firms prioritize resources for their customers based on their CLV estimates. Starting around 20 years ago, there were some very respectable consulting firms that published claims that large proportions of customers were in fact unprofitable and therefore should be fired. Customers can be fired directly, which tends to be noisy and risky for the brand, or indirectly, which tends to be quiet and safer. One prominent example, American Express paid people to cancel their credit cards. That got some attention. And I think we have a general consensus now that we shouldn't blame our customers for being unprofitable. If we have unprofitable customers, we should redesign our offerings and change our prices so that either customers become profitable or they self-select out. And so this idea of firing customers, you have to have a great deal of confidence in your CLV estimates and your customer data to implement this effectively. A simple example is suppose you have a single customer that uses multiple credit cards. If you're not able to identify multiple cards within the customer, you know that you're estimating your retention wrong. And so you may be misestimating that CLV stat. As an example, I graphed the gambling industry's net revenue as a function of customer profitability. So this is from a card spending data set with over 2 million cards in it. And for every card, I could see all of the transfers into DraftKings or FanDuel and other digital gambling like MGM and so forth. And what this shows is that only 5% of the gambling customers were observed to withdraw more than they deposited in digital gambling services. Only 5%. And then you had to go up to the 83rd percentile before the gambling companies, oh, I'm sorry, I said that wrong, up to the 94th percentile before the gambling companies recovered their losses from that 5% of winning customers. And then all of their positive revenue comes from the final 6% of customers. So what the gambling companies do, and this is well documented, although it's not as widely known as it should be, is if you are winning consistently, they either stop taking your bets or they limit the amount that you're allowed to bet. So if you hear somebody talking about gambling repeatedly with a digital gambling service, what do you know about that person? Losers. They're not winning consistently unless they're new. And if they're new, They may ask you in the future to become a beard. To place bets on your account on their behalf, they'll give you a cut. And that may be a good idea. If they've been winning consistently and they've been limited. So it's crazy to me how many people are gambling without realizing that in the long run, the game is rigged. If you're taking money out, they're not gonna let you keep doing that for long. And that's been the advantage of the prediction markets up until now, although unfortunately, I believe that's starting to change. With the prediction markets, you're not betting the house, you're betting against someone else who's using the service. And they're making money on the fees that they take from the bets. But they seem to be changing their structures. And if I were them, I would want to be like these guys, where it's all upside and very little downside. Competition this week is simulating data from some different parameters, using both estimators to train on a subset of your simulations and then evaluate the estimators outside of the training data. If you remember anything, customer acquisition is the most important stat to predict revenue. That's why we focus on attracting customers. Market size estimates how many people share a core need. That is not specific to any individual product, which is something really important. I think that was a common confusion in our discussion. Diffusion models predict how served available market changes over time. And CLV metrics can quantify and enable novel policies. Thank you so much. See you next week. We'll look at marketing and finance. Customer-based corporate evaluation will play an asset pricing game. That is a really cool experience and something you're likely to remember. See you then. Have a great Memorial Day.
Well,